In this video, we're going to talk about two antiderivative problems that are slightly harder than average. So the first one will be the secant of 2x multiplied by the tangent of 2x dx. So notice that if you try to use the u substitution for either of these, you will fail. Okay. So now, all you can do is pretty much rewrite the secant in terms of cosine. So you will get cosine of 2x multiplied by sine 2x over cosine 2x dx. Okay, so that will lead you to sine 2x divided by cosine of 2x squared dx. Okay, so now you can use the u substitution. You can assign the cosine of 2x as the u. The du will be equal to minus 2 sine of 2x dx, and in return dx is going to be equal to negative du over 2 sine 2x, right? So we're going to have, keeping the top written in there, let's have the u squared. Dx is going to be minus du over 2 sine 2x. Okay, so that will give us, let's see. So sine 2x goes away. So we can put negative 1/2 outside the integral, right? Because there's a 2 in the denominator, the negative sign. So we're going to have u to the minus 2 du, right? I'm just writing 1 over u squared as u to the negative 2. Then we're going to have 1/2 as a result, right? Because the power will increase by 1, and so there will be a negative 1 divisor, and with the negative already we'll have a positive 1/2 times u to the negative first, which is 1 over u, right? Okay, plus a constant, and then that's going to give us, in terms of x, 1 over 2 cosine of 2x plus a constant. And keep in mind that 1 over cosine 2x can be written as 1/2 secant of 2x, right? Because the cosine function is such that cosine is equal to 1 over secant, right? Plus a constant. So there goes your antiderivative. Now the second antiderivative will be a little different. It will be the integral of 4 over x to the power of 1 over third times 1 plus x to the power of 2 over third dx. So notice that you can see a relation between the powers here, because one of them will clearly indicate the derivative of the other, right? If you try to take the derivative of x to the 2 over third, you will get precisely the resulting power of x of the derivative x to the negative 1 over third. And x to the negative 1 over third is such that x to the 1 over third is in the denominator, right? So you can set the u freely to 1 plus x to the power of 2 over 3. The du is going to be equal to 3, right? Using the power rule of the derivative, x to the power of negative 2 over 3 dx. So the dx will be, in terms of du, it will be 3/2 x to the power of 2 over 3, right? Because we're going to multiply it to the du. Okay, du, right? So now let's see what we're going to get. We're going to get 4 over x to the power of 1 over 3. And let's introduce the u there because we already have it. So we can just write u. And then the dx substitution is going to be 3 over 2 x to the power of 2 over 3 du, right? And that's going to give us, well, oh, wait a second, I made a mistake. The small mistake, it should be negative 1 over third. I don't know why I did minus 2 over 3. Okay, but in any case, Okay, so negative 1 over a third should be here, right? Right. So that way these guys will cancel. 2 will be canceled, 4 will become 2. So as a result, we will have a 6 outside the integral, and we will have 1 over u du, and that's precisely what we want. So we will get 6 ln. Now let's see, will we need an absolute value for the input of u? So u can only be positive, right? Because in the end you will still square it. So you can square first, or you can take the suppose the x is negative, but you will still get a positive, right? So we don't need an absolute value. So 6 ln u plus a constant, that will give you 6 ln of 1 plus x to the 2 over thirds, right? We're substituting back to x plus a constant. So there goes your antiderivative for this problem. So hope you enjoyed this tutorial. Please subscribe to my channel, and I'll see you in my next video.